I will take up one more problem on finding DFT using properties. So here the problem is given an 8-point time domain sequence. X of n is 11110000 with its DFT x of k. So they have given x of k also for x of n. In case if they don't give x of k, then you have to calculate 8-point DFT of this sequence and then you have to proceed. Fine. So I need to find DFT of these two sequences, and I have to use appropriate properties. Use appropriate properties. So try to solve this. Solution. Now what is x1 of n is given by what? 1 0 0 0 0 1 1 1, right? But so what is x of n? X of n is this sequence, which is 1 comma 1 comma 1 comma 1 comma 0 0 0 0. Now if you find any, can you find any relationship between these two? So what's happening here is, if I shift this sequence left, circularly shift this sequence left 3 times, what happens? So this 1 0 0 0 0 comes at the beginning and rest of the 3 samples goes to the other side, right? If I shift it 3 times, this comes here 1 time, here 2 times, here 3 times, right? And these 3 goes to the other side. So I end up with 1 comma 0 0 0 0 and the other 3 1 1 1, right? So these two are same, but I have written this in terms of this, right? So what is this in terms of x of n? This is nothing but x of n circularly shifted left 3 times, right? So how do I represent it? X of n plus 3 mod what? Mod 8, right? Because the length of the sequence is 8. Okay, so therefore x1 of n is equal to, I can write it in terms of x of n as x of n plus 3 mod 8. Now if I take DFT on both sides, so take DFT on both sides, so I get x1 of k is equal to, so which property I have to use? What is the DFT of x of n minus m mod n? So it is nothing but x of k gets multiplied by e power minus j 2 pi by n into k into, so how many times it is shifted? M times. So similarly here x of k gets multiplied with e power, here I have plus, since I had minus here I have written minus, but here I have plus, right? So it is plus j 2 pi by 8 into k into, how many times it is shifted? 3 times it is shifted. Okay, so I can write it as x1 of k is equal to x of k into e power j, so this is pi by 4, I can write it as 3 pi by 4 into k, right? So this is our x1 of k. What is the next step I need to do? I have to give values for k, varying from where to where? 0 comma 1 comma 2 comma dot 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 up to 7. So x1 of k is equal to x of k into e power j 3 pi by 4 into k. So for k is equal to 0, what do I get? x1 of 0 is equal to x of 0 into e power 0, which is equal to, before that, what is x of k? We have x of k is this, right? What is x of 4? X of 0 is 4. So x of 0 is 4. 4 into 1, which is equal to 4, right? So let me write that x of k. So x of k is 4, 1 minus 2.414j, comma 0, 1 minus 0.414j, 0, 1 plus 0.414j, 0, 1 plus 2.414j. So this is the x of k we have, right? Now if I put k is equal to 1, what do I get? x1 of 1 is equal to x of 1 into e power j 3 pi by 4 into k is 1. So in this, from this equation, right? What is x of 1? Which is 1 minus 2.414j into e power j 3 pi by 4. So e power j 3 pi by 4 is, what do we get is minus 0.707 plus 0.707j. Let me show you. So cos pi by 4, so cos 3, sorry, so cos 3 pi by 4 plus j into sine 3 pi by 4. So it is, if I shift equal to, I get minus 0.707 plus 0.707j, right? So if you do it in a, if you simplify this, we get 1 plus 2.414j. Okay, now if x1 of 1 is 1 plus 2.414j, for k is equal to 7, so this will be the complex conjugate of the last sequence x1 of 7, which is equal to x of 7 into e power j 3 pi by 4 into 7, which will be equal to complex conjugate of this, which is 1 minus 2.414j. Okay, so you can you can do this only if you are confident with this answer. If this answer is wrong, this answer also will be wrong, then the whole problem you get like error. Okay, so now k is equal to 2. What is x2 of 2? Which is equal to 0, right? Why? Because this is 0. So k equal to 3. See, the thing is, if x2 of 2 is 0, what about k is equal to 6, which is x1 of 6, which is equal to this. These two should be complex conjugate, but since this is a real, so I get this as x of 6 into e power j 3 pi by 4 into 6, which is equal to 0. Why? Because 0, 1, 2, 3, 4, 5, 6. 6 is 0, right? Now, so k is equal to 3. x3 of 3 is equal to what? X of 3 into e power j 3 pi by 4 into 3, right? So this is nothing but 9 pi by 4, right? But what is x of 3? 0, 1, 2, 3. X of 3 is 1 minus 0.414 j into e power j 9 pi by 4. So what do we get? Cos 9 pi by 4 plus I into sine 9 pi by 4. So we get 0.707 plus 0.707j. So 0.707 plus 0.707j. So this is equal to, if you simplify this, you get 1 plus 0.414j, right? If this is 1 plus 0.414j, what about k equal to 5 then? So k equal to 5 is x1 of 5, which is equal to x of 5 into e power j 3 pi by 4 into 5, which will be equal to complex conjugate of this, which is 1 minus 0.414j, right? So for k is equal to 4, x3 of 4 is equal to 0, right? Because this is 0, x of 0, 1, 2, 3, 4. Okay, so therefore x1 of k is equal to 4 comma 1 plus 2.414j comma 0 comma 1 plus 0.414j comma 0 1 minus 0.414j 0 1 minus 2.414j. So B, x2 of n is equal to what? 0 0 1 1 1 1 0 0, right? So fine. But what is x of n? X of n is what? 1 1 1 1 0 0 0 0, right? So what is the relationship between these two sequence? This is nothing but, if I shift it right 2 times, so what do I get? These two comes at the beginning and rest of the samples goes to this side, right? So 0 0 1 1 1 1 0 0. And what is this in terms of x of n? It is shifting right 2 times, so it is x of n minus 2 mod 8. Okay, therefore what is x2 of n in terms of x of n? X of n minus 2 mod 8. Now if I take DFT on both side, so what is x2 of n? It is x2 of k. What is x2 of n minus 2 mod n? So it is again circular time shift property, which is x of k gets multiplied with e power, I have minus, so it is minus j 2 pi by n into k into how many times it is shifted? 2 times. But what is the value of n? It is 8, right? So this is nothing but what? X of k into e power minus j. So 2 to the 4, so it is pi by 2 into k, right? Now so k is equal to 0. What do I have? x2 of 0, which is equal to x of 0 into e power 0, which is equal to 4, right? So what is x of k? Let me copy that x of k again. X of k is 4 1 minus 2.414j, 0, 1 minus 0.414j, 0, 1 plus 0.414j, 0, 1 plus 2.414j. This was x of k. X of 0 is 4, so x of 0 is 4 times 1 is 1, which is equal to 4. So k is equal to 1. x2 of 1 is what? X of 1 into e power minus j pi by 2 into 1. What is x of 1? 1 minus 2.414j into e power minus j pi by 2. Cos pi by 2 minus j sin pi by 2. If you put it in your calculator, you get minus j. And if you simplify this, so I get minus 2.414 minus j. Okay, just check your answer. So for k is equal to okay, the thing is, this is the complex conjugate of what? For k is equal to, let me write it here, for k is equal to 7, x of x2 of 7 is equal to x of 7 into e power minus j pi by 2 into 7. This becomes complex conjugate of this, which is minus 2.414 plus j. Right, now x, when k is equal to 2, x2 of 2 is what? X of 2 into e power minus j pi by 2 into 2, but this is equal to 0. Why? Because 0, 1, 2, this is 0. Right, therefore for k is equal to 6 also, x2 of 6 is equal to 0. Complex conjugate, right? So k is equal to 3, x2 of 3 is equal to x of 3 into e power minus j pi by 2 into 3. So what is the value of 3? 0, 1, 2, 3, which is 1 minus 0.414j into e power minus j 3 pi by 2 is cos pi by 2 minus j sin 3 pi by 2, which is equal to j. Okay, and if you simplify this, you get 0.414 plus j. If x2 of 3 is this, what about k is equal to 5? So x2 of 5 will be complex conjugate of this, which is 0.414 minus j. Right, now for k is equal to 4, x2 of 4 is equal to 0. Why? Because this is 0, 0, 1, 2, 3, 0, 1, 2, 3, 4. Right, so I have all the 8 sequence, x2 of 0, x2 of 1, 2, 3, 4, 5, 6 and 7. So therefore, let me write it here, therefore x2 of k is equal to what? 4 minus 2.414 j minus j, 0, this is 0.414 plus j, 0, 0.414 minus j, 0, minus 2.414 plus j. So this is the DFT of the second sequence.